Hi, I'm standing in a Space Lab trainer at the Johnson Space Center in Houston, Texas. It's a little different than the one we used. This one is being set up to train astronauts for the next Space Lab mission. Space Lab is about 7 meters long and about the volume of a small school bus. It was built by the European Space Agency and is designed to be carried in the shuttle's cargo bay. This was our laboratory for over 2 weeks in space on the STS-73 mission, and where we conducted a number of scientific investigations in microgravity. Our mission began on the morning of October 20th, 1995, with an 8.5-minute ride to low Earth orbit aboard the Space Shuttle Columbia. Once we settled into orbit, 277 kilometers above the Earth, the Space Lab module was open for business. Over the 2 weeks which followed, we conducted a total of 24 investigations covering 4 specific areas of microgravity science. The most basic of all the microgravity science performed on our mission focused on fluid physics. So many of the things in our lives are or once were fluids. By studying fluids in microgravity, we can learn more about many of their properties which are normally dominated by gravity-driven forces on Earth. The geophysical fluid flow cell is one of the fluid experiments that may help us better understand the protective atmosphere surrounding our planet, which just so happens to be a fluid itself. Free from the effects of gravity, fluids reveal many of their hidden physical properties in studies like these we performed in a device called the Drop Physics module. Another area of study is biotechnology. Protein crystals help scientists to understand the proteins in our own bodies and how to create more effective medicines to fight diseases. These delicate crystals are grown from solution, and in the microgravity of space, we have been able to grow some of our best crystals. Our material science investigations involve crystals of electronic materials such as those used in your computer. In electronic materials, factors such as speed, efficiency, and reliability depend on the arrangement of atoms in the crystal. Understanding how crystals grow in microgravity may enable scientists to design better electronic materials here on Earth. The fourth area of microgravity science we investigated was combustion. Fire reacts quite differently in microgravity as opposed to the way it does on Earth. Studying the way materials burn and how flames propagate and spread will teach us how to manage combustion and fuel distribution in space vehicles. The knowledge we gain in space may also help us deal with fires here on Earth as well. As my crewmates and I worked long hours in the Space Lab collecting scientific data for scientists back on the ground, the many wonders of our home planet passed by below like clockwork. We were even able to catch a glimpse of one of nature's most powerful forces from our perspective high in orbit, reminding us once again how much of an advantage we gain by being able to live and work in space. We tried to cram as much science as possible into our flight, but eventually we had to come back home. Our trip ended where it began, at the Kennedy Space Center in Florida. In all, we spent a total of 15 days, 21 hours, and 52 minutes in space, and we brought back scientific data that will keep scientists busy for months to come.